Number 65. A balanced three-phase load is rated 200 kVA and 0.62 power factor lagging. A pure capacitive load is added in parallel with the inductive load to improve the power factor to 0.9 lagging. The capacitive load must supply its reactive power kW, that is most nearly watt number. We know this question talk about the power factor improve. We know the most customer use the power meter is only measure the real power. They don't measure the reactive power. So the utility always ask the customer, especially like the manufacturing, the power factor must be reached one number. For example, maybe you must be greater than 0.9 or 0.92. If know this number, the customer will get a penalty. The reason is if it's too low, the power factor is too low, a lot of the loss in the system, or the reactive power is too high. So for this question, we can draw the diagram for the power factor. We know this is a resistor. This is for the inductive. I call this one with system voltage. Because this one is the resistor. This is the inductive. L. So if we draw the diagram, because this is Vs, this is the resistor. The resistor no phase changes. It should be the same with the system power, system voltage. We can draw like this. This called VR. We call vector. This is IR times R. This should be the same phase with Vs. And we know the inductive, the voltage is lead the current 90 degrees. So the current, because this current is IR, the same. So this voltage is VL, is IL, XL, is 90 degrees. So the vector, this is the vector 2. Right? So vector soon should be here. This is VZ equal to VR plus VL. We can get this angle with theta 1. We can get, because the theta 1 is already tell us, because the power factor is 0.62. So we know the phase angle, we call this theta 1 equal to 0.62. So we can get the theta 0.62. What's this number? Anti-cosine. The 5168 degree. The angle. We know the power, total power is 200 kVA. We can find the formula in the page 197. I talk about the AC power. SVI equal to P plus JQ. J is the Vi sine theta. The P is the cosine theta. So you can check the book. You see, the theta is the same because here we talk about the voltage and the current relationship. Actually, it's the same. This talk about the power. This real power. This in reactive power. The relationship is exactly the same. It's equal to P is equal to Q. Q1, right? And Q. And this is for the S. For the S. So we can write down here this power equal to P plus Q JQ1. We can call 1. So we can get this is 200 times cosine theta 1 plus J 200 times sine theta 1. What's this number? We know 200 times 0.62 is cosine. This is 124 kilowatt plus the theta 200 times sine theta. Sine theta is 51.68. This is 157. It's J 157. Okay, 156.9, 157. We know if we get the capacitor in this circuit, capacitor. This is the C. Because the C is added to the system voltage to end here. This, the current, it should be the relationship is the current is the same, but we know the capacitor, the voltage is 90 degree like the current, because this is the system voltage Vs here. So this C should be in this side, 90 degree. Should be this Vc equal IC times XC. This is 90 degree. So in the system, this is go this way, this is go this way. This is totally the reverse. So this should be reduced from this system voltage should be reduced. This one should be put here. So this distance should be the same with this distance. This distance. So this should be after the improved. The system should be like this. There should be here. This angle should be theta 2. Theta 2. So this should be Q2. We know the real power is no changes, only the reactive power change. So this side should be the same. We know this angle because theta cosine theta 2 is equal to 0.9. So theta 2 is equal to what degree? And cosine 0.9 is 2584 degree. 84 degree. So in this triangle, this one here, we know this side is equal to P because the real power is no change. We know this angle, we can get this value for this side because this side divides this side equal to tangle theta 2. So Q2 is equal to P times tan theta 2. What's the P? P is the same, no changes. It's 124 times 25.84. What is the number? It's equal to 124 times 10 into 25.85 is 60 or 60 or is 60 the k watt. So for now we know Q2 is equal to 60 k watt, and Q1 we here is 157 k watt. So now we know the difference between these two. So difference Q equal Q1 minus Q2 is equal to 157 minus 60. What's this number? 157 minus 60. 97 kilowatt. 97 kilowatt. So from here, the question C is close by 98, 97, 98. Yeah. So the correct answer is C.